In this demonstration, you will see how IntegratedML, the SQL-based machine learning feature within InterSystems IRIS, can be used to quickly and easily make predictions based on a set of data. Other learning materials have presented a full-scale InterSystems IRIS for Health application environment that leverages multiple systems to address the issue of patient readmissions. By using an application that assesses a set of patient data and makes predictions on which patients might be readmitted, hospital staff can take preventative action before discharging a patient, potentially lowering their risk of readmission and saving hospitals time and resources. In this demo, we will use a simplified approach, employing IntegratedML to make predictions based on patient data that exists in a single instance of InterSystems IRIS. Here we have an SQL client, dbeaver, connected to InterSystems IRIS. The dataset we're looking at has already been aggregated and prepared for the purposes of our demo. It has been anonymized and cleaned up, but the original data comes from the readmission demo available from the InterSystems Developer Community GitHub account. This dataset contains about 10,000 patient encounter records and 36 different columns. These columns contain a number of important values related to a patient's history: the length of a patient's hospital stay, if they are a smoker, whether they have a chronic condition or illness, the number of past admissions, and much more. These 10,000 records make up the training data we will use to train the predictive model that we create. There are about 4,000 additional records in a separate table, which we will use as our testing data. It is best practice to have different tables for your training and testing datasets, and your two groups should be representative samples. Testing your trained model is important. You want to make sure that it performs well before you begin using it on real incoming data. In the next few steps, we will create a model, train it, and then execute it in a few different ways. First, let's create our model using SQL. This is done by using a create model statement as shown here. The command shows that we are naming the model readmission. Our goal is to predict the will readmit column, which contains the actual result for each patient, a binary answer to whether or not they were readmitted. We are using the encounters1 table, which includes our training data. When run, this command creates a model definition in IntegratedML. Next, we run a second command to train the model. This command is simple. We just include the name of the model we created a moment ago, following the command train model. When running this step, it may take some time. IntegratedML is training our model on a dataset of 10,000 rows. Once the model is trained, we are ready to predict readmission values on the training dataset. This part is the most complex of the three steps, so let's walk through each piece of the command. We'll start by simply displaying the predictions alongside the actual results. For simplicity, we'll select just the top 100 rows. Predict is a function that uses the model we created to make predictions on a given dataset. We will use the results of that function to populate a display column that we'll name predicted readmission. In addition to the predictions, we will also include the will readmit column from the testing dataset, displaying it as actual readmission. This query is run on the encounters2 table, which includes our testing data. The result of this entire select statement will be a side-by-side display of the actual and predicted readmission results for the top 100 records in the table. Let's run this and see what comes back. From this very small sample, it appears the model performed pretty well, but not perfectly. In this particular example, here were some of the results for the entire set. Let's run this query again with an additional display column. We will include the probability function in addition to the predict function. The probability function returns the probability of the prediction being 1, in this case a probability of readmission for a given patient. As we can see, the results now have an extra column that shows the probability that IntegratedML calculated. These probabilities are a huge part of what led to the actual predictions, and can be useful if we want more than just the prediction for each record. Remember, IntegratedML does not replace the role of data scientists in the development of a complex machine learning application. But with a set of clean data and 3 simple SQL commands, you can already obtain some predictions to help identify patients at risk of being readmitted. You could also build models for different scenarios looking at specific patient details. For example, perhaps you find that your model is particularly inaccurate for patients who used to be smokers. You might choose to build a separate model that assesses patients with smoking history to get more accurate results. You have now seen a basic example of how IntegratedML can be used to make predictions on a set of data in InterSystems IRIS.